Okay, our next lesson is 4.2b, graphing linear equations. So the same topic as the last one, only now we're going to take it a little bit further and we're going to discuss domain and range. And again, there's about 6 examples and some notes. And I also will be uploading these note pages as a PDF file if you want to print them out and then take notes onto these pages. It's a little bit less writing for you, so if you'd like to do that, just look for that under your resources or under the calendar. All right, well, let's get started. Make sure you have graph paper, and we'll go. All right, well, this says it's a warm-up, but really it's part of the lesson, and it's what you need to know. And it says, and you'll see questions like this: tell whether the ordered pair is a solution to the equation. Tell whether the ordered pair is a solution to the equation. So it gives you an ordered pair and it gives you an equation. And what you need to do, so you need this in your notes, is that you need to substitute in the given x and y values, in other words, this point, substitute that point into the equation and solve it and see if it is true. So let me show you what we mean. So here we have an equation, and this is your x and this is your y. So you're going to substitute for the y the 3, and then for the x a -2. And so 2y plus x, and then put equals 4. Now, check and see if this is true. Well, 2 times 3, that gives me 6, and 6 plus a -2 does give me 4, and 4 equals 4. So is this a solution to the equation? Yes, because when I substitute the ordered pair into the equation, it makes it true. So let's try another one. Here you have 4x minus y equals 6, and you have this point. Substitute the point into the equation and check and see if it's true. So this is your x and then your y. So 4 times my x, which is -2, minus 1, which is 6. Alright, so let's solve. 4 times a -2 is -8 minus 1. Does that equal 6? Well, no. -8 minus 1 is -9. And -9 does not equal 6. So, no, this point, xy, is not a solution to that equation. Okay, so now let's get on to new material. Alright, so example 3, you want to write this down. It says graph the following equation using a t-table and state the domain and the range. Okay, so the first thing you want to do, here is your equation, -x plus y equals 6. It says make a t-table. So a t-table is just taking a t like that and putting your x and y there, and that's called a t-table. Now it says what we want to do is substitute any value for x and solve for y. Repeat 2 more times, and the x and y values from the t-table will represent coordinates of points on the line. So let's start out, and let's just start with 0. I usually always start with 0, and we're going to let x equal 0. So negative, and then I put in 0, plus y equals 6. Well, -0 is nothing, so that means y is equal to 6. So on my t-table, I would go and put when x is 0, y is 6. So that would be my first ordered pair. Now let's just use simple numbers, and you can choose any numbers that you want. You don't have to choose these, but these are easy to do, 0 and 1 and then 2. So when x is 1, so I'd put in a -1 plus y equals 6, and now I solve it. So that means I'm going to add 1 to both sides, cancels, and y is equal to 7. So when x is 1 on my t-table, when I solve for y, I get 7. And one more time, let's just choose 2, since we'll just go in order. And then -2 plus y equals 6. Add 2 to both sides, and then y we see is equal to 8. So when x is 2, then y is 8. Alright, so remember our initial instructions were to graph the equation using a t-table, So we did that. We haven't graphed it yet, but we have a t-table. So now we can graph the equation, and then we're going to state the domain and the range. So I'm going to pause this, and then you can graph yours. I'll graph mine. All right, so here is 0, 6. There's 0, 6. There's 1, 7. There's 2, 8. I'm not going to write them all out. So I'm graphing, connecting the dots. Not a very pretty line, but that's okay. So is the graph a function? So remember how we tell that? Do the x's repeat here at all? And they do not repeat, so yes, it is a function. I also want to say one new thing that I'm going to teach you here. Another way to tell if this graph is a function is with what we call a vertical line test. Vertical line test. So write that in your notes. And this means that you can look at any graph and you can take a vertical line, such as here. You just draw any vertical line. So draw a line down, or draw a line here, or draw a vertical line here. And if, when you draw one of the lines, if it only passes the graph at one point and one point only, then it is a function. So that's another way to see if a graph is a function, is by the vertical line test. All right, now let's look at the domain. The domain is your x values, and you can see here that your x values, your line goes on and on forever to the left, and it goes on and on forever to the right. So your domain is going to be basically all real numbers. So, and the way you write that is, you can write that with this little R looking thing, or you can put that x is negative infinity to positive infinity. And we put the little set notation around that. So x greater than is in between both of those, negative infinity to positive infinity. Now we'll look at the range, and the range again is up and down, so your y values, and you can see that your graph is going to continue to go up and up and up and up and down and down and down. So again, the same thing will occur for the range, is that it's all real numbers, or the y is less than or equal to infinity and greater than or equal to negative infinity. And infinity just means it goes on and on forever, and we can do the set notation there as well. And that is so not pretty, but you know what I mean. All right, let's go to the next example, example 4. All right, for example 4, again, it says to graph the following equation using a t-table and state the domain and the range. This time we have a different looking equation. We have y equals 3. So we're going to go ahead and make a t-table, and we're going to substitute any value for x and solve for y. So let's do that. So here's your t-table over here. There's your t-table. Draw a t and then put an x and a y there. And then let's just put our equation y equals 3. Well, what if I put x is 0? Well, then what would y be? Y would still be 3, right? Because there is no x in there. So when I put in a 0, then y would be 3. If I put in a 1, then y is still going to be 3. And if I put in a 2, then y would still be 3. Well, this is kind of a weird one because there's no x in there. But we're still able to get ordered pairs. So let's plot these points and see what this line looks like. So we have 0, 3. So I have 0, 3, 1, 3, and 2, 3 all right here. See these 2 points? No matter what I put in for x, y will always be 3. So that means that this is a special kind of line, and it's going to be a horizontal line that goes from left to right. And no matter what value I put in for x, it will always be on this line where y is equal to 3. So let's talk about this. Is this graph a function? Well, if I did the vertical line test and I drew a line anywhere on this graph, vertical line. It crosses the line at only one point. So yes, it is a function. You can also look up here at the table and see that there's the x's do not repeat. Okay. Then if you want to look at the domain is your x values, your left and right, and because you have arrows here, that means the domain is any real number because you have arrows on either end. So it will keep going on. So again, it's all real numbers, or x is less than or equal to infinity, or greater than or equal to negative infinity. Again, using the set notation. And then the range, well, what is the range? Remember, range is the y values, or the values that go up and down, but it doesn't go anywhere up and down except for 3. So the y is always 3. So your range is going to be equal to 3. The only value that y could be is 3. Alright, so what type of line is this? This line is a horizontal line. Horizontal line. And then it says, what is the slope? Well, remember, we can take y2 minus y1. So I can take one of these values here. Let's just take these 2 points. So I can do y2, which would be 3, and subtract y1, which would also be 3. And then I could subtract here the x values. I could subtract 1 minus 0. So I would end up getting 0 over 1, and 0 divided by 1 is 0. So the equation of any horizontal line is going to be what we call a y line. So it would be y equals whatever point that it crosses. This one crosses 3, so y is equal to 3. One way you can remember about these special lines is this is called HOI. So you can write down HOI and see, and I will tell you what each letter stands for. H stands for horizontal, so any horizontal line. The O in the middle stands for 0, has a 0 slope, and the Y means that it is a Y line, which means it's Y equals whatever number it crosses, whatever it crosses on the coordinate plane. It could be y equals, like this line is y equals -3 because it crosses at -3. Then this is y equals 0 right here because it is a y line, it's horizontal, the slope is 0, and it would be y equals 0. So that's a HOI line. Please remember that. Make sure that's in your notes. Okay, so example 5. Again, graph the following equation using a t-table and state the domain and the range. So here we have x equals -4. So in this equation there's no y, only x. So what we're going to do is make a t-table, which we have over here, t-table with x and y's, and we're going to substitute values for y and solve for x. So this is just like the other one, only it's the opposite. So I'm going to let y equal 0. When y is 0, well, since there's no y in the equation, then x is just going to be -4. So I'll put that on my t-table. When y is 1, x is still going to be -4, no matter what. And when y is 2, x is still going to be -4. So here is my table of values that I can graph. So go ahead and graph it, and I will too. So there we have -4, 0, and this is going to be hard to show, but there's -4, 1, and then there's -4, 2. It's hard for me to get it right on the line. It's kind of crazy. But if you do draw the line all the way down, then this would be an x line at -4. Now, is this graph a function? Well, if you look at the table of values up here, you'll see that the x repeats. So no, this one is not a function. And if you were to go and do a vertical line, to do the vertical line test, and you drew a line right on top of it, it would cross at more than one point. So it doesn't pass the vertical line test either. So the domain remembers your x values, and if you look at your table of values here, you can see that x is always -4. So there's nothing else. It doesn't go left and right at all. It just stays here at -4. So the domain for is going to be -4. The range is going to be all real numbers because you have the arrows here, and it goes on and on forever in up and on forever down below. So you would write that -infinity. You'd put a y, you'd put infinity. So y is less than or equal to infinity and greater than or equal to -infinity. And again, you use your set notation. Now, what type of a line is this? It is obviously a vertical line. So vertical line. What is the slope of the line? Well, if we take our y2 minus y1, we can look at our table and we can take y2, I'll take the second point, y2 minus the first y, which is 0, over -4 minus -4. On the top, I would get 1. On the bottom, if I keep change, I get 0. We cannot divide by a 0, so our slope is undefined with a u. The equation of any vertical line is what we call an x-line, and wherever it crosses the x-axis, that's the value of the equation. So x here is x equals -4. So what to learn from here and what to memorize is that when you have a vertical line, it's called a vux, V-U-X, vux. V stands for a vertical line. It is a slope of undefined, that's what the U stands for, and the X means that it is an X line. So it would be X equals -4 in this case. If it was here, it would be X equals -1. If it was over on the right, here we would have X is equal to 3. So all of those are vertical lines. So it'll be X equals whatever, wherever it crosses and wherever it is on the x-axis. Okay, so that's that. Now one more example I think is an application problem and a real-world problem. Okay, so you need to write this problem down in your notes somehow, or you can copy it out, whatever you'd like to do. What we're going to do is we're going to read it. Example 6, a gallon of gas costs $3.50 a gallon. The equation C equals 350 G gives the cost in dollars of pumping G gallons of gas, and you plan to buy $50 worth of gas. So we're going to graph it. The first thing you want to do is identify your variables. C is the cost in dollars, G is the gallons of gas. Then we're going to use the equations and do a t-table. So here's your t-table, gallons and cost. Remember, cost is always y and it depends on your gallons. Remember, G, when you choose values for G, which we've kind of done for you, we're going to let G be 0, 7, and 10, so you want to write those down. G cannot be negative because you can't buy a negative amount of gas. So you have to start at 0 and go only positive numbers. So let's figure out what C is. And so C here is equal to 3.5 times 0. So we're substituting in and we can see that that's just going to be 0. And then if we let G be 7, 3.5 times 7, if you multiply that out, you get $24.50. And then if you let G be 10, 3.5 times 10, then you would get $35. Okay, so graph the points and draw a line is what it says. So we've kind of done this for you, but you're going to need to draw this on your paper. And it says graph those points. So the first point is 0, 0. And then the second point is 7 and 24.50. So I'm going to go over to 7 here and go up to 24.50. Now there is no exact 24.50, so we'll just have to place it in there as close as we can. So it's going to go somewhere about there. Then when G is 10, you'll get 35. So that is that. Okay. So now we're going to draw a line. And remember that the number of gallons, you're only going to go up to 50. So at 50, you're stopping. So you have a closed circle because you're not going more, you're not going to spend more than $50. Okay. All right, so that was number 3. Now look at number 4. How many gallons of gas can you buy with the amount of money that you have? Well, what we can do is we can substitute 50, because that's how much money we have, for C, the cost, and then we can put it into our equation and then solve for G. So if we divide by 3.5, then G is going to be equal to 14.28 gallons. So if I go over to 14.28, that's where it should be, somewhere in here is where it equals 50. Now we get to use this real life example to state a domain and a range. So the domain is your x values. So if you look at your x values, your x starts here and then goes all the way over and stops there. So x, your domain, is going to be 0, and then it goes to 14.28, because that's the maximum number of gallons that you can buy. And then your range, you can see, starts here and goes up all the way, and the total cost that you can spend is 50. So your range also starts at 0 but goes up to 50. And that's how we work that with a real life situation. Okay, thanks for watching. You'll need to write a whisk. When and where did you watch it? Summarize what you've just learned about domain and range and Hoy and Vux and graphing and how to graph from an equation, making a t-table, plugging some values in for x, graphing it, and so on. Okay, thanks for watching, and you will have some homework to do.